So we work on one more problem. Problem 8.59. Problem 8.59. So it has things in friction and centroid. Now a 10-degree wedge is to be forced under MB. B is here. Under of the 5 kilogram rod AB. Knowing that coefficient of static friction is 0.4 between the wedge and the rod and 0.2 between wedge and the floor. Determine the force required to raise and B of the rod. Now, and let's take a look of the numbers here. 10-degree wedge, 5 kilogram rod AB, 0.4 and 0.2. Where are these on the diagram? 10-degree wedge, it means, it means this one is 10 degrees, okay? The second thing is 5 kilogram rod AB, it means 5 kilogram rod, 5 kilogram is let's say 49 Newton. Now 49 Newton, rod AB, A is here, sorry. A is here, B is there. Now the rod AB has a mass of 5 kilogram. So we have 49 newtons going down. So where does the force go? So the force goes here. Go through the centroid of AB. And what is the distance between these two, between the center and the centroid? If this is R, is 0.3 meter, and this one is X bar, okay? This is 5 kilogram rod AB, so 5 kilogram goes like here. Now, about the coefficient of static friction, mu s, 0.4 between the wedge and the rod, and so this one is 0.4 and this one is 0.4, and between the wedge on the floor is 0.2, so this is 0.2 between the wedge and the floor. Let me mark it like this. But of course, we need the angles of friction afterwards. So mu s is equal to 0.4. Phi s is equal to what? 21.8 degree. And mu s is if mu s is equal to 0.2, mu s is equal to 11.3 degrees. So we need to determine the smallest force P required to raise and P of the rod. Now, for the this is 49 newtons, and to draw the free body diagrams, and we have P here, right? P here. After that, so we need to draw the friction forces, and we also need to draw the support force, because there is a pin joint at A. There is a pin joint at A. Now, from where should we begin drawing the forces? Should we begin from here or should we begin from below? We begin from below, okay? We begin from below. So here we have, of course, we have normal force and friction force here. But from here, in this problem, can I simply draw? Can I simply draw the resultant R2 here? R2 here, and this is phi s. Or can I say this is phi s2 and this is phi s1 and this is phi s2? Because we have the mu s here is equal to 0.2, so phi s2 is equal to 11.3 degrees. So phi s2 is here. Remember that P goes to the left, so friction goes to the right. P goes to the left, and that friction goes to the right. So the resultant of friction and normal force is going to the right. And then we go to the contact surface. So first of all, that we have a wedge here. So this is 10 degrees, and then we have R1 here, and this is a phi S1. Because we have the normal force, we have the reaction here and the friction here. Sorry, F and N here. For this N is for this N line is in Chinese. I think you know this is called 法线, right? Sorry. And what is it called in English? It is called surface normal, or simply normal. And this is for this is the free-body diagram for the wedge. Now, after we go to the free-body diagram of the rod. So this is 10 degrees, and this is phi S1. It looks like this. Sorry, this is B and this is R1. Let me make it bigger. So action and reaction. Action and reaction. And the last thing we need to, so it completes the contact surface here and contact surface here. And now we have a pin joint at A. We have a pin joint at A. Do we know the direction of force at A? Of course, you can always draw, AX and AY here. You can draw AX and AY because it is a pin joint, right? But do we know the direction of forces at A? If yes, why? 为什么 because AB is a free force body. So we have the lines of action should go to the same point. So RA should go to this direction. But of course, if you simply write AX and AY, that you get the same answer. But here you can simplify the problem. Remember, rod AB is a free force body. So the three lines of action go to the same point. Before we work on the mathematics, there is one unknown here. This is X bar. We have X bar. So what is X bar here? We have two similar equations. One is R sine alpha divided by alpha. The other is 4R times 3 pi. Which one should we use? Because we have talked about this one and this one, right? We have talked about this and we have talked about this. Which one should we use? To the left or the right? So it is because it is a line it's an arc. It only goes to here. It only goes on the circumference. So it is it looks like a cake, right? So it looks so we use this one. We don't use this one. No. This one is an area, and this one is this one. So it is here we have this is angle is pi over 2. So it is r times sine pi over 2 over pi over 2, which is equal to r divided by pi. Okay, 年轮蛋糕英文怎么说？就是说画上年轮蛋糕嘛。年轮蛋糕英文怎么说？等一下再讲。嗯？ Surface normal. Normal. Now, and so we have all the data we need to draw to do the calculation. So for rod AB, and we can write summation MA is equal to 0. So it is equal to mg and minus So let's look at the free body diagram. Let's look at this free body diagram. If we take, because the goal is to determine P. The goal is to determine P, so we need R1 and R2 to determine P, and we need to determine R1 here. And this is known, and we don't, this is not important. This is not important. So we have, so we take MA equal to 0, so we have one moment going clockwise and one moment going anti-clockwise. Is this going anti-clockwise? Now, and for this force, you can use R cross F, but I would write it in horizontal and vertical directions. This one is horizontal force, and this one is vertical force. And from here we have R1 is equal to 96.68 Newton. And this is, you don't need the angle now, but I just write it down. Of course, you can use R cross F to calculate the moment, but I take the horizontal and vertical components, and I draw it like this. Now, so we come to R1 is equal to this one. And for the wedge, that it is easy, and it comes to the last, same as the last problem. It is and we have these free forces. And this is a rod, let me remind you. This is P, and we have this R1, and this is R2. This one is 11.3 degrees. This one is 31.8 degrees. So what's P? And I forgot. Wait a minute. What's P here? Yeah. I forgot what's the value of P, but I think you can work on it. Oops. This one is what's this one? This one is I forgot the answer, but you can work on it, huh? And because R1 is known 96.68, and this one is this was this angle, and this one is 43.1 degrees, and this one is 70, 8.7 degrees. So P over sine 43.1 degrees is equal to 96.68 Newton divided by sine 78.7 degrees. So P, you can get P. It's okay. So it completes the problem is done like this.